All right, so the only thing now left is this. How should we make that work? We just apply it, right? So what do? 4 equals to u of x0. What's u of x0? Just plug it in here, right? What is that? Sigma n equals to 1 through infinity. That doesn't change. Cn doesn't change. Sine doesn't change. N pi over 2x, that doesn't change.
T is 0.
T is 0, so what happens to there? Becomes 1, right? E to the 0th power is 1. So that's it. Okay, what are we looking at here? We're trying to express 4 as summations of sine with some coefficients. Is there a way to get Cn's? How do you get Cn? Can somebody tell me? I mean, this could be a quiz problem, right? This could be today's quiz problem. I should have used this one as a quiz problem. Huh? This is the sine series, right? Yeah. With L being what?
0 to 2?
Yeah, 0 to 2, right? It's from 0 to 2, right? So L is 0 to 2. Yeah, okay, so give me the formula for the sine series. You should know this, because you have a quiz
1
now.
over L.
2 over, and what's our L?
2 over L.
2, 0 to 2, f of x, which is 4, times sine n pi over 2 x dx. Okay, so that's why we have to integrate. That's just 1. 4 can be pulled out. Just integrate. This integration of sine is cosine with a negative value, right? And 2 over n pi. And there's a 4 in front and there's a minus in front. And then you have to plug in 2 and 0. Alright, so let's plug in 2. The 2 cancels and you get what? Negative 1 to the nth power. 4 times 2 is 8, so let's put negative 8 over n pi, negative 1 to the n. When you plug in 0, what do you get?
1.
Cosine of 0, which is 1. Okay. And then you have, I mean, you can, this could be okay, but I like to simplify if I can. So I multiply negative 1 to here, and negative 1 times negative 1 is positive 1. So it's like really 1 minus this thing, right? So I'm going to write 8 over n pi with 1 minus negative 1 to the nth. And that's the value of Cn. Isn't that nice? So what's the final answer? Where should I plug in those Cn's? That's the final answer. Okay. Now it looks strange, but it is a function, isn't it? It's a function of x and t with no Cn's that are undetermined, right? It's all determined. We know everything about this. If you wanted to figure out the approximate values, we can just truncate this series at some 100 or 1,000, and that can tell us what the shape of the solution looks like. Okay? All right. Now, let's think a little bit more about this solution. What happens if you take limit t going to infinity of uxt? What do you think will happen? where is t? Right here. So what happens if this becomes big? What happens to this? E to the negative infinity, which is 0. So if this becomes 0 and you're adding up zeros, what would happen? This will be 0. Now, physically, does that make sense? Yeah, because what was our initial model? Our initial model was, so you have a rod, and it's inside some insulation so that it doesn't lose any heat over here. The only place it loses heat is touching ice here and there. So ice here and there, ice here and there, so that the endpoints are always 0. Initially, the temperature was 4, so at some point it's going to be like that, and eventually it's going to, the temperature will go down and down and down, and everything will be 0 at time infinity. That's what it means. Now, a slightly more interesting thing would be actually draw this graph for time t equals to 0, 1, 2, 3, and see what happens. Okay. So next time I'll try to come up with some software that can show you this picture. Okay. That'll be also be interesting.